Pre-Algebra. We are starting a new chapter. We are jumping into chapter 10. This is all about data and statistics, which I think is a really, really important topic. We are going to get through chapter 11 and 12 as well. Just barely touch on chapter 11 and get through a good amount of chapter 12 to finish out the year, so we're almost there. But back to statistics, this is a very important part of life, and you probably see all over the news right now, especially so many statistical analysis or things like that. And it's important to understand the concepts of statistics in general. I mean, think about how many things you've seen on the news or heard your parents talk about, and someone has a certain number of cases over here about COVID-19, and someone over here has this many cases, and it's this percentage, and all of those pieces of data are at some point probably true. I doubt people are fully making up numbers, but if they're not accurately assessing it, then it's not true information, and it can be completely skewed. So you could say, oh, well, I'm going to test 20 people over here, and I'm going to say that however many people out of the numbers that I tested is the percentage of people with this virus over in this area, which wouldn't be true because you don't have an accurate sample, right? You've got to have a good number of people. You need a random type of testing. Even if you test it well, the way you look at data can be very skewed if you've got these what we'll call outliers, and if you have a population of people in one town and they're generally very young, or maybe they are all very similar, it's in more of a rural area, and you look at the statistics there, you might think, oh, the virus is really, there's not much going on. And you look around here, like, it's really not a very big pandemic. There's not much going on. But you go to New York City, and it is a very real thing. We have a friend from Dallas who is a nurse, and he actually went up to New York to go help with the crisis, and just hearing some of his stories are just devastating. And you take a population there, and if you think about the amount of deaths he's seen and the amount of trauma and all of these other experiences, and you apply that to the whole world, well, then that's pretty terrifying. So you can't just look at Meadville, you can't just look at New York City, you've got to kind of look at things in a bigger picture. And anyway, all that to say, statistics are very important for you to understand whether or not information is being displayed accurately. And I'm telling you, most of the data that we see out there, I shouldn't say most, but a lot of the data that you might see in some sort of a research project, a lot of it is accurate and a lot of it is done well, but a lot of it, especially on the news and other places, is very skewed. And the way that they talk about it, they put it in their favor. So, for example, I'm just going to kind of scooch this over here and draw you a picture, and then we'll kind of get into the topic here today. If you had a bit of data here, now I could draw a line and say that, hey, this is the trend that we're seeing, okay? Or I could say, you know what, I'm going to actually squish this data. Let me see if I can select this, right? This is the same amount of data, but when I move this, that makes it smaller. How do I make this work? See if I can get it to rotate it. I think I can actually change its proportions, is what I'm trying to do. Okay, I guess I can't. I tried this earlier and it seemed to work. Okay, well, I will just draw you one. Let's say that I took this line here and I kind of squished it in, okay? So if you were to just kind of take these and squish it together, well, then this information and this data is going to shoot up a lot faster, right? Maybe at first you had x equals 10 out here, and now you have x equals 10 out here. It all depends on how you look at the data and how you, this is the exact same information, the exact same line, the same equation, but if you pull the axes out and if you move some things around, you can communicate some very different information to people unless you're doing it accurately. So this looks a little bit more terrifying right here, this yellow line, right? Than this red line. And also if you have some sort of I know we have this exponential growth of viruses, but it also will have to taper at some point at some point you have to approach the population line, right? You can't have more of the virus than there are people in the world, even if every single person had it. That is where there's a limit. You can't go past the number of people. And so there is some sort of a taper off, and there would be a critical point where it would, instead of be increasing, it is now, even though it's going up, it's decreasing, and the rate is decreasing. And so if you just look at this part of the graph right here, I don't think I can zoom in anymore, it looks like it goes straight up. And if you zoom out a little bit, it looks like it's going straight up, but then it's actually tapering off. And so knowing how to use your data well, knowing how to get a population and a random sample of people and having an accurate statistical analysis is crucial. Okay. So why don't you get your books open to chapter 10.1. We are going to take a little bit of vocab here. I know this isn't the most exciting part of everything, but we've got to have an idea, and I want you to make sure you take good notes on this and make sure you know where it is in your book. This will be important information for your assessment on Friday. Okay? So a population, well, what is a population? It's an entire set of objects. I'm reading from your book here, and then we'll summarize. It's an entire set of objects sharing similar characteristics, such as human beings, automobiles, measurements, from which data can be collected and analyzed. So we're going to write this as the set of data, or the set of objects that we can analyze. And we want to make sure we know it's similar too. So we'll say the set of similar data to be analyzed. Analyzed means just to consider, okay? Pick apart, look into, right? Okay, what about a sample? A sample is a portion of the population from which data is collected to estimate the characteristics of the entire population. So, I forgot to write entire set here. I'm sorry. I talked about that and I forgot to write it. That's really important. So the population, think about that. If we have the population of the United States, there are lots and lots of people. I believe there's somewhere around probably 320 million people, maybe more, 300 something, okay? Million people. That's a lot of people, okay? There is no possible way that you could, no matter what you did, actually get a sample or get an answer, right? If you had a questionnaire and you were asking everyone, what's your favorite color? And you're going to make some data. Or maybe you were going to ask if they've been tested for COVID-19. Or maybe you want to ask them if they plan to go to college or not. There is no possible way, or I'm sorry, if they plan to go or have been, I guess that would change depending on their age. But there is no possible way for you to ask every single person in the United States. You could send out an incredible team of leaders and people in every area, and they could go door to door and ask people, but there's just no way for you to get every single person, right? The population is actually the population of everyone, the entire United States, for our example. But because we can't do that, what we're going to do is get a sample. We get a portion of that, and we have to be very careful with what type of a portion we get. And if we get that portion, then we can apply it to the entire population and make a suggestion for everyone. Okay? So that's the whole idea of it. So the sample is a portion of the population, or part. Part of the population from whom data is collected. All right. So for example, if you wanted to ask, we'll go back to if you plan to go to college, if you've been to college, something like that. If you went onto a college campus and asked this question, you're saying, hey, I'm taking a sample of Meadville. I'm going to walk over to Allegheny and I'm going to ask if they plan to go to college or if they've been to college. Is that a good idea? No, you're laughing right now because okay, well, everyone, I guess, asking that question right now, since no one is up there, is a bad idea. Let's say 6 months ago you went up to the college campus and you said, hey, Mr. Crosby, I'm going to ask all of your friends if they plan to go to college. Well, you're going to say 100% of Meadville, Pennsylvania has been to or plans to go to college. Not true. right? That's not a good sample. Why? Well, it's not very random, right? Even if you went to Calvary versus going into just a neighborhood somewhere, we've got people who are committed to school, and versus just a neighborhood where you would have a broader selection of people. That also wouldn't be an accurate assessment. You've got to have a random sampling where there is no bias. Okay, so our sample is a part of it, but it's very important that this part is an appropriate sample to choose. Okay, all right, so let's keep going with our vocabulary here. We're going to speed it up a little bit. The statistic is the measure calculated from a sample of data. Okay, it's the measure. We'll talk about these in a minute. Measure calculated from the sample of data. All right, and the parameter is a measure collected from the data for an entire population. Okay, so they're very similar, but the parameter is when we've expanded it to the whole population. So it's the measure calculated, that click an A. Oops. I guess that's a C there, huh? That looks like an A. Calculated. You guys know what I mean, right? Okay, so the parameter is the measure calculated for the entire, it's from the data still, from the data, but it's for the entire population. Okay, now hopefully you can see that okay. Oops, I guess it's not going to let me put a period there. Could kind of zoom it in there. Okay. All right. Now, if you need to pause this, make sure you get this information into your notes. Make sure you're familiar with where it is on page 392. You will be able to use both your notes and your book on your assessment, as always. All right, so let's talk a little bit about, what is actually a sample versus what is in a population, okay? And then we'll talk about the statistics and parameter, okay? Part of your homework, I believe, is going to be just deciding if something is actually just a sample or a population, okay? No, you actually don't have to do that today. So we are going to definitely make sure we talk about that a little bit more. All right, so I want you to look at skills check 1 on page 393. Let's just go through a couple of these together, okay? So this is skills check 1. Okay, so if you have a few junior high math teachers from some Christian school in Virginia, is that every single person in the whole school population, or is that a part of the people in the whole school for a sample? Yeah, that would be a sample. You don't have every single person in the whole school. Now, it's actually possible, if we were to try to do some sort of a survey at Calvary, it is possible with a smaller population at Calvary that we could actually ask every single person if we were doing some sort of a survey. Now, it would be a lot of work, and you'd have to follow some people around, make sure you really actually got them to answer, or turn their paper back in, or tell you their whatever it might be, and put their tally mark down. But that is possible, although not necessarily important to do it that way, right? So number 1 is a sample because you don't have everyone, okay? What about number 2? 30 of the 8th grade students who attend a large public school. So I'm guessing there's more than 30 if it's a large public school, and you have only picked 30 of all of the 8th graders. So that is also a sample. It's not everyone. Number 3, all of the people who have eaten a hamburger at the Grill Zone. I don't know how you're surveying those types of people, if you can stop them where they come in, but if it says all the people out of a certain group, you know that that's a population. Now, that's not the whole population of the entire world, and not the population of the entire state, but out of what we're looking for, it's all of the people that we're looking for. So that's a population. So if we were to gather some data and say, so from number 1, maybe we said we gathered a few of the high school math teachers and they asked the question, what's your favorite math content? I don't know. You might get a sample of that, and you could say, Okay, well, let's say 80% of your sample, 80% of them, maybe you asked 10 teachers and 8 of them said that they really, really love polynomials. I don't know. Okay, 80% of them said that of your sample. Well, this right here is a statistic, right? And if we were to say, okay, well, I surveyed out of 10 people, but I know that there are 20 teachers in the whole school, math teachers in the school, let's say it's a pretty large school. If I were to apply that and say 80% of all of them, or approximately 16 of the teachers might say that polynomials are their favorite, well, then that's a parameter. See, I've applied it to the larger population, even though I didn't actually ask all 20 teachers, right? Okay. We are going to kind of skip over number 4 and go to a few more pieces of vocabulary here. So this vocabulary is on page 293. And these are different types of ways that you can sample people. We talked about how important it is to sample the right amount of people and the right types of people. You have to be very careful not to have a bias. Okay, so like we said, you can't ask all college students if they plan to go to college and actually apply that everywhere else. It wouldn't give you an accurate assessment. And now, obviously, that's kind of a silly example because you could figure that one out clearly, but it's very easy for people to do that. If you even just simply surveyed your friends at school instead of a general population of everyone, there's a little bit of a bias. You tend to have friends who are a little bit more like you, and so you might be interested in the same things. And so if you asked a question about some interest, well, then that also has a bias if they just happen to be your friends instead of really getting one random person from every grade level. Or, we'll talk about the ways you can do that. But it's very important, okay? So let's take a look at some of the ways here. So random is what it means, what it sounds like. Random number generator is usually used. You actually could get a random number generator if you have a graphing calculator. You can Google a random number generator. And if we were in class, we'd probably do a few of these. I have a friend who has a small business on her Facebook page, and when she picks the random winner from whoever comments on her post, she gives them all a number, and then she uses a random number generator, and it generates a random number, right? And then whoever matches that number is the person. And that way there's no bias that goes with it. So it's just often a random number generator is used, and you match that person up, right? So random is just a sample that you don't actually pick who it is. There's an outside source. You could, if you had 6 people, you could roll a die, right? And you could say, okay, I numbered everybody 1 through 6, and if you roll a dice, that's a way to generate a random number, okay? So we're going to write this one down as a random number generator being used to determine each person in the sample. You might give every person a number, or you might group them off into, okay, all of 5th grade, pull a random number, and that's your one person from 5th grade. Then all of 4th grade, pull a random number. So you can group people and use a random number. You wouldn't have to do a random number of the entire school. Might help to have a feel for every grade level, something like that. Okay, I'll give you a minute to write that one down. Systematic. Systematic is where you might have everyone listed probably alphabetically. So the example in the book is a phone book, and you just say, I'm going to pick every 10th person. Number 10, number 20, number 30, number 40. Okay, there's a pattern to the person that you pick. However, it is not, there's no bias involved. So you don't tend to really like country music more just because your last name starts with an R. Okay, there's no correlation between that. And all people who really love pop music, they're at the beginning of the alphabet. That's not how it works. And so systematic is just a number that you would pick, and you go through everyone listed in either a random order or in alphabetical order or something like that. Some sort of an order has no bias to it. Okay, so let's define this one. So we'll say every 10th, or you could use whatever number. You could use 13th, every 2 people, depends how many people you might want to survey. Every 10th number of people who are listed in some way without a bias. Example, alphabetical. Okay, the third way is a convenience. So you might have a questionnaire with a return envelope, and it's mailed out with the phone bill, and you're trying to ask every person with a phone who has, answer a certain question, okay? Now, it depends on what kind of a question you're asking. Most people have a phone, and this book was written back when you had probably a landline there. But if I surveyed people on an internet survey, it seems like, it's out to everybody in the whole world. Well, technically, there's not a bias in terms of you have to have a certain last name or you have to live in a certain area, something like that. But there really is a bias even if you do an internet survey, because not every single person has access to the internet. And so generally, there are lots of people who make the choice to not have the internet. We make the choice not to have a television in our house. But a lot of the time, most people do in a certain social economic standpoint, right? And maybe some people are in more of a rough financial situation, and so they aren't able to afford the internet. And so their voice matters just as much in our survey. And so it's very important when you think about surveying. Now, it depends on the type of question. Maybe it's okay to have a bias of only people on the internet. But we got to think about that. So convenience is something where you just send out a questionnaire and people can mail it back in or can submit it on the internet. It's probably a little bit more common right now. But it's something where you have the people generally just right there and they have to fill something out. Okay, so maybe you're at church and you kind of hand out a sample questionnaire to everybody. That would also be a convenience. They're just right there. You give them something, they fill it out. Okay, so let's see. We'll write something here where we say people are given a survey because they all share a common place, or, the example, if they all have a phone bill, you send it out to everyone there, or maybe a purchase. So if everyone's all in one place and you kind of hand something out, that's generally what it'll be like with a convenience type of sampling. Okay, now they don't actually have to physically be in a place. A lot of the time it will be they're all here and we kind of pick that. But a lot of the time it could be, this is a group of people, they all have a phone bill and I'm going to put that in the mail to them. Okay, last one is called a cluster. And so a cluster is actually an intentional bias in a way. It's everyone who lives in a particular area of town. You might have a cluster there, or you might want to poll just the 8th grade because the question applies to 8th graders, okay? So you have a specific group of people when it comes to a cluster. And it's an intentional group of people. So you survey an intentional group of people. Okay, it's not like the whole nation, the whole school. It might be just all the 8th graders, or just all the people who stay after school for sporting events, right? Maybe you're wanting to have a questionnaire to see what type of snacks you should have at the snack bar. It wouldn't matter if you have a group of people who never come to a sporting event what kind of snacks they want, because they won't be the ones to purchase it, right? You would want to survey a group of people who might be affected by the decision you're making. Okay, this is not on your actual homework assignment here. However, I do want you to think about, do you think you could kind of judge some of these, okay? Numbers 1 through 14, numbers 1 through 14 in your book are going to be challenge questions, okay? So if you try those, you will have to pick from either where did I have this here? Here we go. A sample, population, statistic, parameter, or a random, systematic, convenience, or cluster type of sampling. Okay, so if you try those for challenge, that's kind of what all that information is. Today, we're going to, I know we've spent a lot of time talking about that because I think the idea is important. This next part, we're going to rush through a little bit more because this should be very much review. for you, and your book gives it in pretty clear detail also. But we're going to go over the range, the mean, the median, and the mode. So we'll define those. If we were in class, I would call on you because I think you probably know most of these and just need a refresher on how to find them. And we'll find all 4 of those with some given data. Okay, so we will go a little bit more quickly through this. This is your homework tonight, to find range, mean, median, and mode over a certain grouping of questions. Okay, so the range is the difference from the smallest and the biggest. Okay, so that's how far apart is your data spread. So I'm going to kind of zoom in here a little bit and we'll talk about these vocabulary words. Please write these down. So this is the difference from the largest to the smallest. Which is one reason it's very important to have your data in order from least to greatest. And you often will have to put it in order. It's not going to come in order. Okay, the mean is another word for the average. And how do we find the average? We need to add up all the numbers, and then we'll divide by the number of numbers. And we'll go over that in a little bit here. Okay, go ahead. If I'm going too fast, just pause it. Okay, median. The median is the number in the middle of the data. Now, sometimes there are 2 numbers in the middle. We have to find the average between those 2. But this is just the middle number. Okay. I guess we should put that so that it's the average between numbers if 2 fall in the middle. Okay. You don't just pick 2 medians. Okay, and then the mode is the number that occurs the most. Okay, and so when you hear mo, there's a lot of M words. So if M-O, I think most, you probably heard that before. So the number that occurs, number that occurs the most. Okay, I'm going to show you all of these here in a minute, and you can kind of get this if you still need it. So we're going to find the range, the mean, the median, and the mode for my data that's right here. But my data, what do I have? I have a bunch of numbers. I'm going to need to know how many, but I also don't have them in order from least to greatest. So that is my first thing. Now you can order them from smallest to greatest or from greatest to smallest, descending or ascending order. It doesn't really matter. They just should be in some sort of an order. Your book actually says to do descending order. I've always done ascending order. It really doesn't matter. So you can pick whichever one you want. All right. I'm always going to go from smallest to largest because that's just what I'm comfortable with. If you want to do the other way, you're welcome to do that. Your list would look the same, just kind of backwards, okay? So 3 is my smallest. I always cross them off once I use them so that I don't accidentally use something twice. All right, now I guess the next one would be 5, and then 6, and then there's 1 7, but I have 2 7s, so you have to list both of them. Oh, there were 2 6s. You probably saw that I missed that. So easy to miss stuff, so just be really careful while you do that. Maybe go a little slower than I was. 6, 7, 7, 9, and 10. Okay, now I'll make that look a little bit more like a 10. Okay, so what we have here are, let's count them here. 1, 2, 3, 4, 5, 6, 7, 8 numbers. That's important to know so that we can find the average. Okay, so the first thing we need to do is find the range, and the range is how far apart are they from here all the way down to here in a number line. So I'm going to take my largest number and subtract my smallest number. So my range in this case is 7. All right, the mean Again, if you're struggling with these or you need some more to practice, you'll have some for homework tonight. Please reach out if you're struggling with these because I'm not going to spend a lot of time in this video. It really is mostly review. Okay, so the mean is going to be the average of them. So the first step that I need to take here is to add them all together. If you want to use a calculator for this, I'll let you do that, okay? Let's see, when we add these all together, I think I did this earlier, 53. And how many numbers did I have? Well, I had 8 numbers. So remember, we're going to add them all up and then take that number and divide it by the number of numbers. Okay. Now, generally, your average is going to be written as a decimal. So you could write it this way or you can write it this way. It doesn't really matter. You'll get the same thing. And it's going to be approximately 6.6. We're going to generally round to the nearest tenth for our class. Okay. Go ahead and use a calculator if you need to for that. This is going to be the mean. All right. The median. Median is the number in the middle. So I'm going to use a yellow here and I'm just going to come. Now, the middle number when they're in order, don't find the middle over here. You're going to get the wrong median. Okay, you need to have them in order to find what's in the middle. So I'm going to cross one off from the top and the bottom and just kind of keep doing that until I get to the middle. Okay, now I'm stuck with 2 in the middle. So I don't say that my median is 6 and 7. I say that my median is the average between those two. So I'm going to take 6 plus 7, and I have 2 of those numbers. So add them up and divide by the number of numbers, right? Just like we did over here. Add them up, divide by the number of numbers. So that gives me 13 halves or 6.5, right? Now, you might be able to just look at that and say, oh yeah, well, halfway between there is 6.5. I'm showing you the process because sometimes your numbers are not going to be that simple in order to find the median that way. In this case, it was. So there is my median. Lastly, my mode. I need to know what occurs the most. And in this case, you can have more than one answer. The median, the range, and the mean all can only have one answer, but for your mode, you may have more than one. And it just depends on whichever numbers are used the most. So in this case, we have a tie, and 6 and 7 are used twice. So our mode is 6 and 7. Okay. Let's do one more example and then we are going to be done. We need to find the range, the median, the mean, the mode for all of this data. Okay, first step is put them in order. So let's see, 38 looks like my smallest. Then I have 41. Then I have 42. Then I have 44. Oops. And 45. Then I have 49 and 50, 58, and 60. Okay, when I'm listing them, I don't need my brackets anymore. In order to find my range, I'm going to subtract the smallest number from the largest number. All right, so if we subtract these two, we'll get 22. So my range is 22. All right, let's find my mean. It doesn't really matter which order you go in. I'm just going to try to stick with the same order. All right, if we add them all up, I'm not going to show you adding these all up. Okay, use your calculator. Add them up. If you don't have a calculator at home, if you have some sort of a device, you can Google a calculator. When you add them all together, you should get 427. Now, I still have to divide that by the number of numbers, right? And I didn't count that yet. So let's count that. 1, 2, 3, 4, 5, 6, 7, 8, 9 this time. So divide this by 9. You could also write it as a fraction. That's the same thing as division, either way. And you should get 47.4. Remember, we're going to round to the nearest tenth. That is our mean. All right, the median. Remember, we're just going to kind of count it down. And because we have an odd number, we're going to have a number in the middle. Okay? That means 45 is my median, and that's it. I like when they're that way, right? All right, and the mode. Now, do you remember? The mode means most. Think back. Do you remember if there isn't any number used twice or more than twice? They're all used once, so it's all a tie. So do I say all of them are my mode? well, no, that's not helpful. The data is all there. I have it all. The whole point is to gather some information from it. So even though you can have more than one, excuse me, you're not going to say all of them. That's not helpful. So we just say none, and that is it. All right, well, I'm not going to have you practice any of those with me because you are going to try 4 different ones like that for homework tonight. Check your answers. They're listed under the lesson plan tab. Try the challenge if you're up for it. Let me know if you do the challenge, so I give you extra credit for that. So just shoot me an email or put that on your chart for the week when you finish that up. Okay, well, miss you guys. Can't wait to be back together again.